Assalamualaikum warahmatullahi wabarakatuh. My name is Sft4043 A1. Today I would like to present about boiler water reactor (BWR). BWR is a type of nuclear reactor used for generating electricity. It operates by using nuclear fission to produce heat, which in turn generates steam to drive a turbine connected to a generator. What is BWR? BWR is a type of nuclear reactor uses ordinary water, which is like water, as both its coolant and its moderator. I will explain more details in the next part. Next, from this figure shows in general overview of the structure and components of a boiling water reactor BWR. It consists of reactor vessels, control rods, fuel elements, pump, steam line, turbine, generator, and cooling water. BWR has some different with PWR, where it is also one of the types of basic nuclear reactor. Firstly, coolant and moderator. In a BWR, ordinary water, which is like water, serves as both the coolant and moderator. The water in the reactor core boils and directly produces steam that drives the turbine. While in a PWR, there are two separate water systems. The primary system circulates high pressure water, known as the primary coolant, which absorbs heat from the reactor core. This water does not boil and remains liquid. The secondary system, separated from the primary system, produces steam for the turbine by transferring heat from the primary coolant to a separate water loop. Secondly, steam generation. In a BWR, the steam is generated directly within the reactor core as the water boils due to the heat produced by fission. The steam, along with any and rainwater, is separated from the remaining water using steam separators and then sent to the turbine. In a PWR, the heat from the primary coolant is transferred to the secondary coolant using a heat exchanger, which is steam generator. The secondary coolant in the steam generator then boils to produce steam, which is directed to the turbine. Thirdly, reactor pressure. In BWR, the reactor pressure is lower than a PWR. The pressure vessel of a BWR operates at a lower pressure to allow for the boiling of water within the reactor core. While in the PWR is higher compared to a BWR. The primary coolant in a PWR operates at a higher pressure to keep the water in the primary system from boiling. Lastly, control rods. In BWR, control rods is typically inserted from the bottom and raised or lowered to control the nuclear chain reactor and adjust the reactor power. In PWR, control rods is typically inserted from the top and lowered to control the nuclear chain reaction and adjust the reactor power. These are some of the key differences between a boiling water reactor BWR and a pressurized water reactor PWR. Next, we will go to the properties and characteristics of a boiling water reactor. Firstly, boiling coolant. BWRs utilize ordinary water as both the coolant and moderator. The water boils directly in the reactor core, producing steam that drives the turbine. This distinguishes BWRs from other reactor types, such as pressure water reactors, PWRs. Next, single coolant loop. BWRs employ a single loop design where the boiling water flows directly from the reactor core to the steam separator and then to the turbine. There is no separate primary coolant loop like in a PWR. This simplified design reduces complexity and potentiality lower costs. Next, moderate power density. BWRs operate at a moderate power density. This ensures efficient heat transfer and simplifies the design of the reactor core and associated components. The next property and characteristic is lower pressure operation. BWRs operate at lower pressure compared to PWRs. The pressure vessel in a BWR maintains a lower pressure to accommodate boiling water in the reactor core. This simplifies the design of the pressure vessel and associated systems. Next, direct steam generation. PWRs directly generate steam within the reactor core. The steam, along with any rainwater, is separated from the remaining water using steam separators. This eliminates the need for a separate steam generator, simplifying the system design. Next, core and fuel flexibility. BWRs offer flexibility in core design and fuel options. The core can be modified to accommodate different fuel configuration and enrichment levels, allowing for efficient fuel utilization and flexible operation. The next point is simplified safety systems. BWRs employ simplified safety system. They design incorporate passive safety features and relies on neutral circulation and gravity-driven systems for emergency cooling and shutdown. Next point is radioactive contamination. BWRs, like all nuclear reactors, produce radioactive byproducts. Effective containment and radiation shielding systems are crucial for managing and controlling radioactive contamination. Boiling water reactors have distinct properties and characteristics that make them a viable option for electricity generation. The direct steam generation, simplified design, and flexible fuel options contribute to their operational efficiency and safety. Next, we go to the function relation. The function relation in a nuclear reactor describes the relationship between the various components and their functions in the process of generating electricity. While BWR and PWRs are both types of nuclear reactors, they have some difference in their function relations. For BWR function relation, firstly, steam generation. BWRs directly generate steam within the reactor core through the boiling of water surrounding the fuel assemblies. The steam carries the generated heat energy and is used to drive a turbine for electricity generation. Coolant and moderator. In a BWR, ordinary water serves as both the coolant and moderator. Water flows to the reactor core, absorbing heat from the fuel assemblies and undergoing boiling. Control rod function. Control rods made of materials like boron and a combination of boron and silver are inserted into the reactor core. The control rods regulate the nuclear chain reaction by absorbing neutrons, controlling the reactor's power output. The function relations in BWRs and PWRs highlight the unique processes involved in generating electricity from nuclear power. BWRs directly generate steam through boiling water in the reactor core, while PWRs transfer heat from the primary coolant to a secondary coolant loop for steam generation. BWRs use water as both the coolant and moderator, whereas PWRs utilize separate materials for this function. Besides, control rods play a vital role in both reactor types, regulating the nuclear chain reaction and controlling power output. Lastly, we will discuss about the applications of boiling water reactor. Firstly, electricity generation. BWRs are primarily used for electricity generation. They produce heat through controlled nuclear fission, which is used to generate steam to drive a turbine and produce electrical power. Secondly, baseload power. BWRs are well suited for baseload power generation. They can operate continuously for extended periods, providing a constant and reliable supply of electricity to meet the baseload demand. Next, flexibility in power output. BWRs offer flexibility in adjusting power output to match change in electricity demand. They can be started up and shut down relatively quickly, allowing for responsive operation. And lastly, research and development. BWRs are used for research and development purposes in nuclear science. They serve as testbeds for studying reactor physics, fuel behavior, and safety analysis, contributing to advancements in nuclear technologies and reactor performance. Thus, boiling water reactors, BWRs, and pressurized water reactors, PWRs, have distinct application in the field of nuclear power. BWRs primarily focus on electricity generation, baseload power, flexibility, and research and development. PWRs have broader applications including electricity generation, nuclear propulsion, desalination, and industrial heat generation. The versatility and reliability of both BWRs and PWRs contribute to their significance in meeting energy needs and addressing various challenges. In conclusion, PWRs have simpler design and passive safety features, while PWRs have higher power densities and advanced active safety system. Understanding the differences between PWRs and PWRs is crucial for selecting the appropriate reactor type for specific application and operational requirements. That's all from me. Thank you.